All right, so we're going to talk about hyperbolas today. Hyperbola's equation actually looks super similar to an ellipse equation. So if you go ahead and look at these two equations, they're very similar. They're fractions, they're equal to 1. They both have the h and the k. They have the a squared and the b squared. But there's a couple of differences that I want to point out. So one is that it's going to be a subtraction. And then two, look at the a squared and the b squared. Do you see how that a is always first? That's something that's unique to hyperbolas. That's going to be different from ellipses. Remember, ellipses, a was always the bigger number, and a kind of moved around. So remember, your a always matched up with your vertices. So if your major axis was that horizontal, that x-axis, well, then your a value was going to be with the x. But here, okay, it's the same idea. So notice that a is always first, but now my x and my y are moving around. So your a is still always going to be with your vertices, but your x and your y move around, and that's going to tell us which direction the hyperbola is going to open. So your center is going to be at HK, just like it has been for all 4 of the conic sections now. We're going to have an equation for our foci, very similar to the equation for the foci with the ellipse, except with the ellipse equation was addition, and the foci equation was subtraction. So it flip-flops. Here, the hyperbola equation is subtraction, so the foci equation is going to be addition. Okay, so a squared plus b squared equals c squared. All right, the vertex is going to be the distance, and we're going to call that distance a, just like we have been. From the center to a point on the transversal axis is the technical name. But if you really want to kind of think about what we've been thinking of, this is going to be our major axis. Okay, there's no major or minor axis because a hyperbola is actually just 2 parabolas that are either both opening up and down or left and right. Now we have something different in hyperbolas, and that's going to be an asymptote. It's going to be a line that helps us draw the end behavior of the hyperbola. And I'll kind of show you how we deal with that. It's just we're going to draw a box and we're going to connect the corner of the boxes, but it's going to have a slope and it's going to have a y-intercept, so it's technically a line. Now your asymptote, remember, is going to be a line that your graph never touches, but it gets super close to. All right, so let's go ahead and try a couple of graphs. So the first one here says graph the parabola and then identify all this important information. So if we look at this first one, there we go, we're going to look for the center. So the center is going to be 0, 0, because look, there's no parentheses with those x's and y's. Now my vertices are going to go with the a value. So remember that a is always first. So if a squared is 9, then that means that a is 3. And then my b value is going to be the other one. So that means b squared is 36, which means that b is 6. And my a is going with my x, and my b is going in my y direction. Let's go ahead and just find c right now, just because we can. So remember that c squared comes from a squared plus b squared. So c squared is going to be 45. We're just going to go ahead and round to the nearest tenth to get that c is 6.7. That's going to be how we figure out where our foci are. So if my center here is at 0, 0, I can go ahead and put that center at 0, 0. Now my vertices are in the x direction. So that means I'm going to go x to the right 3 and x to the left 3. And I'm choosing 3 because that's what my a value is, and my a matches with x. Now these are my vertices, so that means that those are where the branches of my hyperbolas are going to be drawn from. Now we don't have co-vertices here, we just have other points, so we can go ahead and use these other points to help us draw our box. So my b value is 6, and that's going to go in the y direction, so I'm going to go up 6. I'm just going to put a little teeny tiny dot, and I'm going to go down 6. Again, just putting a little teeny tiny dot because it's not a super important dot. Okay? What's important is it's going to help us draw our box to get our asymptotes. So if we want to kind of think about these 4 points helping us create a box, we're just going to go ahead and do a dotted line until we get on the same line as that x equals 3. And then we'll go all the way down until we got on that same line of y equals -6. And then we'll go all the way until we get to the x equals -3 line. And then we'll go all the way up and then we'll finish our box. So what that's going to do is that's going to help us draw our asymptotes. All we really do is we connect the lines corner to corner. So I'm going to make a line that goes from corner to corner, kind of going through that 0, 0, that center point to help us. So what that does is that gives us the branches of our hyperbola. So here's my vertex, and then I can go all the way out to that green line and all the way out over here. So we can see that the mouth of this hyperbola is super, super wide. Here we go. And we'll do the same thing over here and over here. And then again, super, super wide. So these purple lines are actually what the hyperbola is. The green asymptotes and the box, that is not what your hyperbola is. Your hyperbola is just this figure right here. Okay, that's it. We just have the other things that just kind of help us draw them. So now if I want to go ahead and fill in all my important information, my vertices are going to be these 2 points right here, which I'll get from my graph as -3, 0 and +3, 0. My C value is where my foci are going to be, and that's going to be at 6.7. So we don't ask you for your foci here. I'm not really sure what happened with that, but we will graph it. So our foci are 6.7 from the center. So I'm going to go 1, 2, 3, 4, 5, 6.7. I'm going to put the focus right there. And then I'm going to do the same thing on the left side. So I'm going to go left 3, 4, 5, 6.7, and I'm going to put my focus there. So we do want to make sure that we are sketching those foci also in a hyperbola. This is a perfect drawing, okay? I would totally accept that. I don't really want to see the naked drawing, let's call it that. Okay, I do want to see the box there. I want to see your asymptotes on the lines and all of that. The last thing we're going to do is we're going to write the equation of our asymptotes, and the equation of our asymptote is going to be the equation of a line. So that means we're always going to have y equals. Now notice that this green line has a positive slope and this green line has a negative slope. They both have a y-intercept of 0. So all we're going to write is plus or minus, and then it's just your slope, your rise over a run. So I went up 1, 2, 3, 4, 5, 6, and I went over 1, 2, 3. So I went up 6 and over 3. Now, we can never actually leave our answer like that because that is bad math. And this is a line, so we'll put an x because that's the slope. So you want to change that to y equals plus or minus 2x. That's going to be the asymptotes that we're looking for. Notice that the 6 and the 3 right here, that's my B and my A values, okay? Because I went up B value and I went over A value. That's going to be important because if you don't have a nice A or B value, a nice whole number like you have a fraction, you're going to want to be able to figure out which direction your A and B are so that you can leave it as a fraction. We're never going to want to have any sort of decimal, so you'll leave it as fractions and radicals. Okay, let's try another one. Okay, so I needed a new piece of paper. That one was kind of squishy. The first thing we want to notice about this is that this is not in our standard conic form because it's got coefficients in front of the x's and y's and it's equal to a number other than 1. So the first thing we have to do is get that equal to 1. The way we're going to do that is just simply by dividing by 16. So we'll divide every piece by 16, and then we can simplify those fractions and we'll see that we'll end up with y squared over 4 minus x squared over 2 equals 1. So that's what we're really going to be working with here. Remember that A always comes first, so we can go ahead and say that A squared is 4, which means that A equals 2, and that's going in that y direction. I just like to remind myself which direction it's going in so I can remember which way my hyperbola is going to open. And then I'm going to see that B squared is 2, which means that B is the square root of 2. Okay, I know that that's pretty ugly, but we'll deal with that in a minute. That's going to go in the x direction. So now if I want to figure out what my C value is, I'm going to use my foci equation. C squared equals A squared, which is 4, plus B squared, which is 2. So that's going to tell me that C squared is 6, which means that C is about 2.4. So we're just going to go to 1 decimal there. Okay, so we can start kind of sketching this. We can see that the center is going to be at 0, 0. The center is at 0, 0 because there's nothing with the parentheses with those x's and y's. So if I put my center on my graph here, now I know that that A value is 2, and it's in the y direction. So that means I'm going to go up 2, and I'm going to go down 2. And I'm going to put nice big points there because those are my vertices. That's which direction my hyperbola is opening. That y is coming first, so it's opening in that y direction. And then my B value, the square root of 2, is going to be about 1.2. 1.64, 1.4. There we go. So then we can go ahead and draw our fancy little box. So this one's going to be in the middle of the boxes, and that's okay. Just do your best, sketch your little box there. And then we're going to want to go ahead and connect the corners to the corners. And draw in those asymptotes. Make sure you really make those lines nice and long, filling up your graph. Okay, what that's doing for us is that's kind of giving me the boundary for the branches on my hyperbola. So now I can see that I'm going to go and follow those green lines. And I have a little bit more of a narrow hyperbola than the last example. Okay, so those are my vertices, these ordered pairs right here. This negative 0, negative 2, and then 0, positive 2. Those are my two vertices. My C value, we already did the work. We already saw that that was 2.4. So let's go ahead and just sketch those points on our graph. So remember, that's coming from the center. So up 1, 2.4, just barely over the vertex on either side. Now the last thing we're going to want to deal with is the asymptotes. So I'm sorry if you're running a little bit out of room here. Your asymptotes are always going to be y equals plus or minus something, and that's the slope. So as we think about the slope, we went up 2, and then we went over that square root of 2 value. So this is what I was talking about in the last example. You're not going to want to change that into a decimal. You're going to want to now rationalize and multiply by radical 2 on top and bottom, and see that you have 2 radical 2 over 2, and then those cancel out. So my asymptotes are actually at y equals plus or minus radical 2, that's my slope, and then x. Now there's no y-intercept because here is my y-intercept at 0. We're only going to ever ask you for the actual asymptotes when it's centered at the origin. If we move it around, well, then we've got to do a whole mess of things, and we're not going to deal with that.